Hi guys, earlier in the term we looked at negative numbers and now we're going to use those same ideas for algebraic expressions. So the first thing to remember is if you're multiplying two expressions together with the same sign, the answer is going to be positive. If you're multiplying two expressions with different signs, the answer is going to be negative. So that's like our first idea. So let's have a look at that briefly. Got an example over here. The coefficient has a positive sign, the a has a positive sign, the answer is going to be positive. The coefficient has a positive sign, the pronumeral has a negative sign, positive times negative will be negative, different signs. Negative 2 times negative a, we have two negative signs, the answer will be positive, just like it was with multiplying negative numbers. And the same goes for division. If we've got a negative and a positive, the answer will be negative. If we've got two negatives, the answer will be positive. Now, when we're writing expressions with multiplication signs, typically we just remove them because we don't need them in algebra. But if it's unclear, use a bracket. So over here we've got 2 times a. We write that as 2a. Over here we've got 2 times negative a. Now, if we hadn't put the bracket, it would have been unclear whether we were multiplying and then subtracting or doing something strange. So by putting the bracket there, it's quite clear. It's 2 multiplied by negative a, and 2 times negative a would be negative 2a. Now, if we have an expression separated by a division symbol, remove the division symbol and express it as a fraction. So over here we have a division symbol. So I replaced everything immediately after the division symbol and put it underneath as a fraction. And that's quite easy to do. There are some gotchas that we'll look at further when we do a fractional algebra topic later on. Now, convention in algebra is to first write coefficients, then pronumerals in alphabetical order. So you'll see over here, well, in all of these cases, in fact, we've got a coefficient and then the pronumerals in alphabetical order for each expression. Let's have a look at one that's not. Just say we had 2ab, that's not a b. We had 2ab times 4ac, that would equal 2 times 4 times, let's do it in 2 steps so you can see what I mean. 2 times a times b times 4 times a times c, that's just expanding it out. Now, because multiplication is commutative, I can change the order for everything that I'm multiplying. 2 times 4 times a times b times c. You can see that I've rewritten these now in order, numbers first and then alphabetically, and then I simplify. 8 times a squared times b times c, which is simply 8a squared bc. So when we're writing our solutions, we need to be mindful of this convention and write coefficients first, then pronumerals with their attached indices or powers in alphabetical order. Let's have a brief look at this very last example down here. We've got 12a squared b cubed divided by 4a cubed b squared. And I want to show you one simple thing that you can do to make your simplification easier. I did the coefficient first, so 12 divided by 4. Then I wrote the a's on top of each other, a squared on a cubed, and then the b's on top of each other. And then I simplified them out. So I know, just looking at this little bit here, I know that a squared on a cubed is equal to a times a squared times 1 is still a squared, a times a is a cubed. I also know that a divided by a is 1, so 1 times 1 will just give me 1, times by 1 on a, 1 times 1 on a is just 1 on a, and that's where this comes from here. And I did something similar for this. If you can get that idea in your head quite clearly, it'll make a lot of those fractional questions a lot easier. If you have any problems with that, post a question and I'll do a few more examples in detail. Thank you, everyone.